Okay, in this video I'm going to go over 9.2, which is area of oblique triangles, which is kind of weird. We might not know that word. Area of oblique triangles. So oblique is just a fancy word for meaning not right. So it's not a right triangle. And this is actually a case that we are going to have to use a different formula than the normal triangle formula. So the two cases that we have a right triangle where it's super easy. We have the height, we have the base, we know the area is base times height divided by 2, which is what we discussed in 9.1. An oblique triangle would be something that is either obtuse or acute. So we'd have to find the height in order to do that. And again, area is still the same formula. If we're not given the height, we can calculate the area given side angle side. So without height, the height, we can find the area or calculate the area using side angle side. So side angle side basically means that we have two sides in the included angle. The order matters, like we did when we, like we know it did, when we were using this as congruency theorem and as we were using this for similarity to prove those two things. So I want to know if I'm giving you this triangle. Here's an example. We're going to figure out the formula together. I say to my empty classroom. We're going to figure it out together as like you and me. Starting with this triangle, I'm going to call it A, B, C. And I'm going to tell you that I have angle C, which is 49 degrees. Nothing special about 49 degrees. And I have 3 of the sides. I have all 3 sides. So I know that this side, and this is definitely not drawn to scale, this side is 5, this side is 4, and this side is 7. So I want to know what is the area of triangle ABC. My thing is we need to figure out the altitude. So we're going to drop down an altitude. You can drop down the altitude from either of your 2 sides that we don't have. I think it'd be easiest to drop it down from the top. You can always turn your paper and orientate it differently and drop it down from B. And you're just making a altitude, which means going from the vertex to the opposite side at a right angle. So I'm going to drop down my altitude, and that is what my height is. I need to figure out what the height is. So to do that, I am going to use trig. Because now I have a right triangle. I can ignore all of this and just use this imaginary triangle right here. That doesn't really exist. In fact, I'm going to highlight it so we can kind of point it out and focus on in it. So there's my right triangle. We are going to ignore everything else. So which one of my functions am I going to use? Am I going to use sine? Do I have the opposite in hypotenuse? Am I going to use cosine? Do I have the adjacent in hypotenuse? Or am I going to use tangent? Do I have the opposite and adjacent? So let's go ahead and label what I do have. I'm using angle 49. So across from 49, I'm looking for that. So I am going to use the opposite. So I have to have either sine or tangent. I don't have this value right here. I have the whole side, CB, but this is like CD. This is not the entire length. So we can't use the adjacent. We would use the side that's across from the right angle, which is the hypotenuse. So we're going to use sine because we have the opposite in the hypotenuse. And we always use sine. This ends up working every single time because we're discovering this formula. It is true for every single triangle given side angle side. And it's a fun formula to remember. So we're going to use sine of the given angle, which is 49 degrees, is equal to the opposite, which is my height, over my hypotenuse, which is 4. And now I just want to find out what is h. I'm going to multiply both sides by by 4 to get h by itself. So I know that h in this case is whatever 4 times sine of 49 degrees is. So you can type that in your calculator and get an estimation of it. In fact, that's what I'm going to do now. And make sure you're in degrees mode. So 49 sine, that's sine of 49 times 4. I get, it's like about 3. So I'm going to keep this number in my calculator, but I'm going to use this in my formula. So my area is equal to 1/2 base times height, or base times height divided by 2. So I know my base in this case is where the height meets the base, so that's 7, times my height, which is this mess, 4 sine of 49 divided by 2, or 1/2 of that. And that's what we're going to get. We already did that in my calculator, so I'm just going to multiply by 7 and then divide that by 2. And you get your answer. And I think rounding to the 100th would be good. So looking at that 6, round it up because of the 5. So 10.57. And I didn't give you units. Let's call these centimeters. So this would be centimeters squared for area. So let's break that down into the actual formula. So the formula is going to be area equals the two sides that you have. So side times sine of the included angle all of it over 2. And it's really just fancy, like another way of doing it is area is equal to A times B times sine of C all over 2, or 1/2 of that. And that's where we have the case where my angle is C and my two sides are A and B, if that makes sense. So that's the formula, and that was how we derived it. I have 2 examples that we can try these ones, but since this is just a demo, I'm going to stop the video here.